Hi everyone. Today we are going to discuss the most important topic of chemistry with respect to JEE-mains and NEET, that is Grignard reagent. Grignard reagent is one of the most important topic, and today we are going to discuss what is Grignard reagent, how they form, what kind of reaction they show, and in the last we will solve the problem related to JEE-mains which are appeared in the previous year of 2021, 2022 and so on. So let's get started. The topic Grignard reagent. Grignard reagent is also called organometallic compound. The term organometallic compound referred as organo means carbon, metallic means metal. When carbon is directly bonded with metal, then it referred as organometallic compound. And one of the most important organometallic compound is Grignard reagent. And this Grignard reagent is written as RMgX. It is also called alkyl magnesium halide, where R is any alkyl or aryl group. It may be CS3 MgBr type compound, CS3 CS2 MgCl, phenyl magnesium bromide or halide, any halide except fluorine, any alkyl magnesium chloride bromide iodide except fluorine. Okay, such type of compound alkyl magnesium halide are called organometallic compound, or this type of organometallic compound are referred as Grignard reagent. If RMgX type of compound are present in question, then how we solve the problem related to RMgX, that is Grignard reagent, when we have such type of compound is given. So student, we will see further what Grignard reagent give to us, like RMgX. What provides? It provides R minus and Mgx plus. This R minus is act as a strong base as well as a strong nucleophile. So generally it will give two type of reaction. One is acid base reaction and another is nucleophilic reaction. So we will see further what kind of reaction can show Grignard reagent. Okay. Next, what is the preparation of Grignard reagent? How we can prepare the Grignard reagent? Grignard reagent can be prepared by when alkyl halide on treated with magnesium in presence of dry ether, then it will give RMgX, that is Grignard reagent. For example, methyl chloride on treated with Mg dry ether may be CS3 whole twice O, dimethyl ether, it will give CS3 MgCl, methyl magnesium chloride, is an example of Grignard reagent, as well as CS3Br, or you can say, you may take another example, like if any cyclic compound and joined with halogen, then after reaction with magnesium in presence of dry ether, here Et means ethyl, so it may be methyl, ethyl, any type of ether, but should be dry ether, and here magnesium insert between carbon and halogen and form Grignard reagent, alkyl magnesium halide. Many more example, chlorobenzene will react with Mg in presence of dry ether, will give phenyl magnesium chloride or benzene magnesium chloride. Many more examples, CS3CHBr, CS3 2-bromopropane will react with Mg in presence of dry ether, will give CS3CH MgBr. Mg will insert between the CH carbon and halogen and will make a Grignard reagent. Many kind of Grignard reagent can be prepared when alkyl halide are treated with magnesium in presence of dry ether, it will give a Grignard reagent. And the most important thing is what Grignard reagent provide to us. The Grignard reagent provide to us a strong alkyl anion, that is carbanion, which act as a tremendous base, a strong base, and will also can act as a strong nucleophile. So if we discuss here, we have the variety of halogen like fluorine, chlorine, bromine, iodine. Then what kind of halogen connected with carbon will give the faster reactivity, which show the strong formation of Grignard reagent, such as RF generally do not form Grignard reagent because the carbon and fluorine bond is much more stronger and it cannot break easily. RMgF generally not form. RBr or RCl, any other halogen except fluorine can form Grignard reagent, that is RMgCl and RBr Mg CS3. Any dry ether should be there, that is why reaction between RBr and Mg, we can prepare RMgBr, alkyl magnesium bromide. And if we talk about alkyl iodide on reaction with Mg and dry ether, will give RMgI, and all the four reaction which will give faster. So the order of reactivity will be RI should be greater than RBr, should be greater than RCl, should be greater than RF, and generally RF will not give the Grignard reagent, because the R and F bond is much more stronger, where R is nothing but any carbon related compound in which R may be alkyl, aryl, anything, whereas Ri can, the bond between Ri can break easily because the size of R, that is carbon and iodine, have much more difference. Smaller size of carbon and larger size of iodine have very weak type of force of attraction, very weak type of bond present between both of them. So it can be break easily. That is why the order of reactivity will be higher in case of alkyl iodide as compared to RBr, RCl, and RF will not give generally. So next we are going to talking about the nature of bonding in RMGX. So if we talk about the bonding present between RMGX, generally RMGX is represented as like this, in which R single bonded with Mg and connected with halogen. We will talk what kind of bond present between RMG and MgX. This is the basic concept of the nature of bonding in RMGX. Every student should to know what kind of bond present between them. So first we are going to discuss the bond between RMG. RMG type of bond are covalent in nature, and it can be explained by Fajan's rule and difference of electronegativity. When we apply this both concept, then we will find then the type of or nature of bond present between carbon and magnesium will covalent in nature. But here we discuss the actual nature between carbon and magnesium is it has more covalent character and have less ionic character. But the bond is generally regarded as covalent because the more covalent character is dominant on ionic nature. That is why RMG type of bond is regarded as covalent in nature, and it can be explained by Fajan's rule, which are the part of chemical bonding, and also the difference of electronegativity. The difference of electronegativity can explain the type of bonding. Like if we discuss the electronegativity of carbon is roughly regarded as 2.5 and magnesium has 1.3 something, and the electronegativity of halogen are, we all know the halogen have very high electronegative element in all periodic table elements. So roughly we are discuss the electronegativity of chlorine, that is 3.5 if we'll take the rough value of all these elements, carbon, magnesium and chlorine. So the main concept is if the difference of electronegativity, if the difference of electronegativity between two elements in compound is, if it less than 1.7, then it have more covalent and less ionic. It will be more covalent and less ionic. And if the difference of electronegativity is more than 1.7, the process will reverse, and which indicate less covalent and have more ionic in nature. If we are going to discuss the difference of electronegativity between carbon and magnesium, so we will found that the difference 1.3 something, 1.2 something, and here we can see easily that the value of electronegativity is less than 1.7, then the bond will regarded as more covalent and less ionic. And if we talk the difference of electronegativity between magnesium and chlorine, roughly you can replace this chlorine with bromine and iodine as well, but we have a rough data, so we can easily explain the concept. But this concept generally explain on the basis of both, that is Fajan's rule and difference of electronegativity. The difference of electronegativity between magnesium and chlorine will roughly found that 2.2, which is more than 1.7, which indicates it has more ionic character and less covalent character. So here, what is the conclusion? The conclusion is the bond present between RMgX. The bond between RMg, that is carbon magnesium, regarded as covalent, but all or every student should to know these covalent have some ionic nature also. Okay, this bond contain more covalent character and less ionic character, and the bond between magnesium and halogen will be more ionic and less covalent, so regarded as roughly ionic bond. So two type of bond present between RMgX, that is covalent and ionic. Both type of bond is present. Okay. So what is next? Next is the chemical property. As we earlier discussed, the character of RMgX when it undergoes into the chemical reaction, it will provide R minus and MgX plus. R minus is regarded as a very powerful base, that is very strong base. Since it acts as a strong base, then it will give generally acid base reaction, and the acid base reaction is very powerful or very fast reaction. So first we have to check the given compound is acid or not, and next, if the given compound is not acid, then the R minus will act as a strong nucleophile, also can give nucleophilic reaction also. And this nucleophilic reaction can be categorized into three parts. The one is The one is nucleophilic addition reaction. Another is nucleophilic addition elimination reaction. Addition elimination reaction. And another is nucleophilic substitution reaction, which is also called SN reaction. So generally the Grignard reagent will give such type of reaction. First we have to check the given compound is acid or not, because acid base reaction is very strong reaction, very fast reaction than other reaction like nucleophilic reaction. So first we have to check the given compound is acid or not. The acid, any compound which have active hydrogen, and the active hydrogen are those hydrogen in which hydrogen is connected with more electronegative element like halogen, and here halogen may be anything, fluorine, chlorine, bromine, iodine, or OH type bond, NH type bond, or if any compound like this, it can easily release H plus and make aromatic itself. So the compound, if the compound release after H plus and is stable itself, then it can release easily H plus. So such type of compound are also release H plus and can act as acid. Also, these compound have also active hydrogen. Okay, so all these compound can act as acid. So here when the Grignard reagent react with such type of compound, it will attract H plus ion and compound contain which have R minus combined with R plus and form generally alkane. Okay, here is the some example related with acid base reaction where base is our Grignard reagent. So the example is CH3 MgBr after reaction with water will form CH4 plus MgBrOH. CH3, same compound will react with different type of acid and will give the compound like CH3D MgBrOD, and it can also react with this compound and will form methane and as side product. There are so many examples related to acid base reaction in which base is our Grignard reagent. Here NH3 ammonia generally regarded as base, but in case of strong base it act as a weak acid and it will give H plus to Grignard reagent and will form methane, and MgBr NH2 will another compound. So this reaction is generally regarded as acid base reaction, and so many reaction where Grignard reagent can react with acid will give respective product. Okay. If the given compound is not acid, and how can we identify that given compound is not acid, then compound will be it may be carbonyl. It may be carbonyl. Generally, carbonyl compound are not regarded as acid. It have not active hydrogen. That is why it have nucleophilic center, that is carbonyl. This carbonyl is act as nucleophilic center. Here, any nucleophile can attack easily. This is a nucleophilic center, in which carbon directly bonded with oxygen, and we all know oxygen have more electronegativity than carbon. So partial charge generated on oxygen and carbon, that is partial negative, partial positive. Any nucleophile can attack on this carbonyl carbon and will form a product. Like if we take some example, Grignard reagent CS3 MgBr react with formaldehyde, acetaldehyde or formaldehyde, then CS3 minus can react on this nucleophilic center, and this pi electron will shift on oxygen more electronegative atom, CS3 CH2 O minus and MgBr plus. This type of compound is the intermediate between the product formation between reactant and product. So if it take hydrogen from solvent, will give a product of CH3CH2OH, that is 1 degree alcohol, ethanol, 1 degree alcohol, and plus MgBrOH will be the side product. Next example, if we have another aldehyde than formaldehyde, any aldehyde than formaldehyde, then it will give a secondary alcohol. Any aldehyde, the same mechanism can happen here also. So it will give the CH3OH, and this compound is isopropanol, and this is the 2 degree alcohol. Okay. And we will see some other example. Like if Grignard reagent RMgX react with CO2, that is carbon dioxide, then it will give carboxylic acid. It will give carboxylic acid. That is RMgX on reaction with carbon dioxide, the R minus, and here carbon attached with oxygen have polarity and generate partial positive, and the oxygen contain partial negative. The R minus can attack on carbon to form a bond, like this. And if it take any proton from solvent or any other compound, then so it will give RC OOH, that is carboxylic acid and other product like this. So student, we can see easily when any Grignard reagent on reaction with carbon dioxide, then it will give carboxylic acid. It may be, these are maybe any alkyl or aryl group, maybe any alkyl or aryl. That is, if we talk some example, CS3 MgBr on reaction with CO2 with solvent, then it will give CS3, one carbon which is already present in the carbon dioxide, and another R may be obtained from Grignard reagent. So it will give the carboxylic acid of how much number it will provide of carboxylic acid, the total number of carbon which contained by Grignard reagent, and one is from carboxylic acid. So here is one carbon present in Grignard reagent and one is in carbon dioxide. So it will be give the carboxylic acid of 2 carbon, that is CH3COOH. Okay, this is the main product, and the further remaining the side product will be also obtained. Next, if we take phenyl magnesium halide, that is phenyl magnesium chloride bromide anything with CO2, then it will give benzoic acid. Benzoic acid, very important compound, that is benzoic acid will obtain by the reaction between benzene magnesium chloride or benzene magnesium halide on reaction with CO2 will give benzoic acid. Grignard reagent on reaction with SO3 will give sulfonic acid as a product. It will give sulfonic acid as a product. For example, if CS3 MgBr on reaction with SO3 in presence of any proton donating compound, then it will form CS3 SO minus double bond O and MgBr plus, and after protonation will give CS3 SO3H, that is methyl sulfonic acid. Methyl sulfonic acid. Next, if Grignard reagent can react with on reaction with RCO L type compound, where L may be any living group. L may be any living group. So, and living group may be chlorine, bromine, iodine. Already we discussed the carbon fluorine bond is much more stronger. So here we are not going to take the example of fluorine. Okay, chlorine, bromine, iodine, or any alkoxy group or any other bulky group etc will give, generally they give secondary, tertiary alcohol. For example, if we take CS3 MgBr on reaction with CS3 COCl, okay, then it will give first a ketone. We can solve the direct and the form direct product ketone, that is acetone, and further reaction, if we have excess of the reagent, then it will react further and can form 3-degree alcohol. Generally they form 3-degree alcohol. And L may be anything, chlorine, bromine, iodine, alkoxy group or ester group or any bulky group which can leave easily. Okay. Now it is the time to discuss the previous year's question. Okay. The question first is appeared in 2004 JEE-mains exam. So what is the question? Acetyl bromide react with excess of CS3 MgI followed by treatment with saturated solution of NH4Cl give. We'll see solution. Acetyl bromide, that is CS3COBr, on reaction with excess CS3 MgI. This is in excess. So what will it give? It will give CS3 OH, CS3 and CS3, because this is in excess amount and it can eliminate the living group, that is bromine. We already discussed bromine can eliminate and ketone is formed, and after that ketone can also react with Grignard reagent and will form 3-degree alcohol, and the name of this alcohol is 2-methyl propane 2-ol or 2-methyl 2-propanol, that is option will be C. Okay, you can solve easily problem if we have the proper concept regarding to Grignard reagent. Now next, compound A undergoes following sequence reaction to give compound B. The correct structure and chirality of compound B is, where Et is C2H5, MgEt, any alkyl bromide, any alkyl chloride, any alkyl iodide. Simple. If any alkyl chloride, any alkyl bromide, any alkyl iodide are on reaction with magnesium in presence of dry ether, will give what will give? It will give Grignard reagent. Grignard reagent. Okay. Now the next is when it react with D2O, and D2O is slightly here act as acid and it can provide D plus to this compound. So it will form such type of compound which can maintain its chirality. The chiral molecule does not loses chirality in such type of reaction. So this will be the option. This will be the compound and molecule will be chiral. So option will be C. Now next, question number 3 is appeared in JEE-mains 2021. In the following sequence of reaction, the P is. Now you can see easily an cyclic alkyl group with chlorine on reaction with magnesium dry ether. What will give? It will give alkyl magnesium halide, that is Grignard reagent, and after reaction with ethanol, that is ethanol is CH3CH2OH, where this kind of hydrogen is known as active hydrogen, and it will give the hydrogen to that compound, then compound will form, and another is MgCl and OH. Okay, so the option will be C, because the ethanol can provide H plus to this compound, and here acid base reaction can perform. Acid base reaction can perform. Okay. Next question, 4th. For the following sequence of reaction, the correct product. This question is appeared in second shift of JEE-mains 2021. Okay. So first, if benzene on reaction with bromine with presence of iron or iron bromide will give bromobenzene, and if once bromobenzene is formed, then after reaction with magnesium dry ether will give phenyl magnesium bromide, and after reaction with methanol, where methanol have active hydrogen, can provide hydrogen, and product will be benzene. You can also write this benzene, or according to option you can show the hydrogen, and the next product will be OCH3, which are connected with magnesium and bromine. So the option will be D. Okay. Now the next question is the product formed in the first step of the reaction. Here a compound having 2 bromine group is attached. So this compound on reaction with excess MgEt2O, that is diethyl ether, will give all carbon magnesium bond are feel that it has insertion of magnesium between them. So you can see easily without any restrictions. This will be the final. And if it react with any solvent, then it can form a general alkane of 1, 2, 3, 4, 5, 6 carbon. So CH2 4 times and CH3. But we have to draw the structure only one kind of product like this, because we have not given any solvent. So the final option will be B.